Hello everyone, and welcome to the GreenSQL webinar for this month. And today we're going to talk about database security best practices for software as a service platform and software as a service infrastructure. So as you all know, I guess, and this is already, let's call it a common information those days, that the number one security challenge those days is without a doubt information theft. And something really tremendous happened in 2011 when the FBI have named that the organized data theft is a bigger criminal industry than drug trading. And this brings a very important, let's say, issue to the fact, because if we'll take the recent breaches of the past 2 years, we can see that those are major attack on most of them a cloud-based infrastructure. Doesn't matter if they provide a software as a service, or it doesn't matter if it's stored inside of a cloud infrastructure. The thing is that most of the information those days was stolen from companies that provide services on the cloud. And why am I mentioning that? Because when FBI named it a bigger criminal, actually than bigger crime and a crime industry than drug trading, the thing is that if 10 years ago or even 7 years ago, stealing 300 records of customers was a big deal, and if they were stolen from a bank or some sort of financial organization, companies would have complained and it would have been a big deal. Today we can see that almost on a monthly basis, some major company with a huge customer base, I'm talking about millions and sometimes tenths of millions, have been breached and the entire information have been stolen. I'm not saying that the 50 million live social members information, which include email, date of birth, or even encrypted password, doesn't matter if it will be decrypted or not. The thing is that this specific information is not the big deal. The big deal that with this information, you can extremely easily generate an identity theft. And the identity theft industry is one of the biggest plagues that's happening now, not only in the United States, but worldwide. If with this information only, I can create and forge actually a credit card, or I can forge ID and go to the bank and open a bank account on your name, take a loan for $10,000 and just disappear. Eventually, the police will come to your house and you will have no knowledge whatsoever how exactly it happened. Many times we use the same password with the same resources. For example, a lot of people use their Evernote password as the same password they use on Gmail, and their same password sometimes they use on PayPal, and so on to their eBay account. So it means that only if people steal about 25% of the passwords that were stolen can and will be used in order to attack your mailbox. And after that, they will just go and press remind me the password in PayPal, and it will eventually lead to a full exposure. But now we are talking as on software as a service. And the architecture that you see in front of you, this is a very standard enterprise high-level design of a company that was, I assume, very average of an enterprise, very average infrastructure until 10 years ago. Something very tremendous have happened the past 10 years, that a lot of different solutions that you can see inside of this enterprise, and this specific enterprise is sort of a telecom company, have migrated to a cloud-based services. For example, the CRM services. Salesforce today hosts, I guess, about more than 50% of the Fortune 1000 companies and providing them CRM services. Billing solutions are available online. GIS solutions are available as a service. Mediation services to integration with whatever infrastructure that you can imagine are available globally. Unified messaging system. You just take a look at Gmail and how it really changed how even telecom think. And if this was a very basic enterprise architecture up to 10 years ago or something like that, today you can see that more than 60% of the services besides the core infrastructure that provides the service inside this telecom or inside a financial organization is being used as a software as a service provided by major companies those days that you can get online for less than 1/10 of the amount you've paid for creating your own infrastructure. And all this information, all this extremely sensitive information, eventually is stored inside the software as a service platforms. And this is something we have to take into consideration when we think about privacy, when we think about security, when we think about what exactly can and should happen in high-level companies. And this brings me directly to the motivation for database security. Database security solutions are available in the market only for the recent 7 to 9 years. Until then, all companies were focusing on perimeter security. Doesn't matter if it's a firewall solution, intrusion prevention system, a content filtering, even information leakage prevention system. And as time passes, we see that people started to understand that the database is the company. And when you're a software as a service provider, your database is a lot of different companies. It doesn't matter if you hold some sort of financial information or HR information or customer information or even some private information from companies, you are actually the company. And as I just said before, if you are a software as a service company, you become the companies themselves. And there are two main connections connecting to these databases that provide as a service. There's the user connection based, which means your DBA access, your IT operational team, your developers, your QA, and even sometimes casual users. And on the other hand, we have automated connections. A lot of backup solution, replication solution, any kind of an ETL application that just drops the information from the database, runs some sort of a script or any type of manipulation command to the database and load it back in order to continue. Maybe it's a BI system and so on. And those two types of connection actually provide you the understanding about what's really happening with this type of information. Trying to think about the threat level and who can actually cause a threat, I created some sort of a threat economy. And how exactly things are happening today in this world. From the writers of tools, of viruses, of malicious code to spywares, the first stage abusers who exactly run those types of attacks. Sometimes it's the same users, sometimes it's the same organizations. Hackers have evolved. Today, there are full financial programs that finance those actually attackers. So trying to understand the threat economy and who exactly should they target in order to get as much information in the lowest amount of time. And that brings me to the point that you have to take into consideration the thing that that database, even though is the company, or in a case where we're talking about software as a service, is the multiple companies, the thing is, and the most important thing that you have to take into consideration is what's called the attackability surface. And when I'm saying a surface, what exactly and where exactly the database is located? Who are the sources that can actually get to the database? One of the most basic examples that we see almost on a weekly basis is that a customer says, listen, I see that those specific commands are running from the DBA computer, and this is legit. He's using the IP address of the DBA computer, he's accessing using a specific application the DBA use, and he's even using the DBA credentials. But the fun thing is that the DBA is on a vacation. And there shouldn't be any commands running from the DBA computer inside the network. And this brings additional question to the entire process. Who exactly generates the type of command that you think that are ran by your authorized users? And the attackability surface, besides the fact that we're talking about an operating system, you have to take into consideration the entire threat surface. You have to understand that even if a computer is authorized and using the credential, who exactly is the entity that runs the command? If the browser of your DBA computer have entered a link that runs a malicious code that cannot be detecting using common antivirus solutions, then the computer who is infecting your network and actually running the commands to your database is not the DBA. It's a malicious code or a Trojan horse that was installed on this computer, and someone got control of this machine. And taking it one step forward, many times when you're a software as a service provider, your database runs on the server. the database is not a black box. And this is something that you have to take into consideration in order to see the full attackability surface of the system. And the attackability surface, when we are talking, for example, on Microsoft SQL Server, we are talking about any of those attack vectors can lead to a successful breach. And why exactly am I mentioning that? Because many times we see customers that install multiple third-party applications on their database server, and at the second that someone can get access to the operating system and can just copy two files, and this specific example is on a Windows server, but most of the software as a service solutions run it on a Linux solution, it doesn't matter. When someone can gain access to your solution, to your operating system, they can gain control of the operating system, and they are running everything that they're interested, and stealing your information won't even alert your DBA or your database. In Microsoft SQL, it's all about copying two files. In MySQL, it's even just dumping or copying one file without the need to be authenticated in your database application. So at this point, I would like to explain that the attackability surface is the main thing that people have to take into consideration. Without a doubt, the number one attack today in the market is still SQL injection. And it doesn't matter how much people will spend time on securing their application solution, how many database application security solution, application firewall they will acquire, which is important, no doubt. We still see that the number one attacks running in the market is SQL injection. And just to explain you how common it is, many different pen testing, which mean penetration testing companies that evaluate security level for customers' applications, says that more than 65% of the clients turn out to be vulnerable to some sort of a SQL injection solution. And this is a very interesting flaw because OWASP have released a 2013 report just a few weeks ago, and they also mentioned that the number one threat for any kind of organization is still SQL injection attacks. And a lot of times people say, yes, but I'm using Informix database. It's an old legacy database that it's probably not vulnerable. Or I'm using some sort of only reports can access my database. Almost any database is vulnerable to SQL injection attacks. And almost any application providing some sort of a layer in order to run successful SQL injection attacks. The recent 2 years, something very interesting happened. SQL injection was started to be discovered in a closed source application, which means that even if you have a client server application that you run on the DBA desktop or even maybe on your customer desktop, SQL injection can run through this tunnel as well. If you're talking about web applications, so you have several different ways in order to secure your access to the web application. If it's by acquiring a web application firewall, or maybe it's even by just hardening the application that someone or you have written in a web application environment. But when we are talking about a closed source application, a client-server application, you have no actual way to secure this type of access to your application, nor to the database that the application uses. So it's really important to understand that, as I mentioned before, the database is the company. The reflection that you have to take into consideration is your database, which is eventually the company. SQL injection character, I'm not going to go through it, but you can see that there are a lot of different variation and a lot of different mechanisms in order to a successful SQL injection command to run through the system. You can get a lot of information about this online, and I'm sure you can get this. SQL injection have evolved like any other attack in the market, and today it's not only about getting information from your database or not getting information from your database. SQL injection, even though it starts with a basic input validation and goes to the information gathering, about trying to get as much information as possible from your web application and from your database, even just generating some sort of an error system that will be forwarded back to the web application in order to get information regarding which database is being used, which version it's currently running, which operating system runs this database server or even web server, in order to get as much information as possible. And when we're talking about software as a service, you have huge platforms that are providing the information for your customers. And as I mentioned before, attackability surface. Security is not a magic word. You can't just buy yourself out from security threats. It's a full wide range of solutions that you have to implement in order to mitigate multi-layer attacks and multi-layer security flaws. And the SQL injection methodology, right after the information gathering, the attack starts. But the attack is not just about retrieving information, it's about getting some sort of an OS interaction. And the OS interaction comes in order to increase the influence of the SQL injection attack and eventually get some sort of a shell command or some sort of a running commands to the operating system in order to expand the influence and start attacking different computers and servers. About once a week, we get a call from a company that says that they have no clue how someone took over their internal server, that it's not even connected to the internet. And many times these are companies that are running in a cloud environment, in private clouds. But the web server eventually was vulnerable to some sort of a SQL injection attack that eventually led to a full operating system interaction, and it led to expand the influence and to start attacking additional servers at the back end. And I'm not talking about the web application. When I'm saying attacking servers at the back end, it starts with a database. But eventually, it can continue quite easily to attack any server that is located in your data center, and from that to any PC available and got access to those servers. So the result of a successful SQL injection attack can be not about only bypassing login information or getting information from the database. It can lead to a full rainmaking of attacks, from attacking additional computer to implementing backdoors and starting attacking other users that use your service. Just 2 months ago, one of the biggest, I guess, information companies in the internet today that provide software as a service, when a user just tried to log into the system, someone have implemented a malicious code to the customers of this company. And that happened really easily by someone that had a SQL injection running, and they have actually implemented an iframe inside of the web application, but only when a customer tries to log in. Which means this is probably a customer using the system. If the SQL injection attack was already working, it means that they already got his password. They were able to run some sort of an attack on his browser, and they might have been able to take control of the system of the user who tries to connect to the software as a service. Which means, what exactly is the threat that you have to handle with? It's the entire architecture. You have to take into consideration multiple layers of security that you have to mitigate in order to make sure that you are not providing the information. And when we finally get into the database, and it's really important, we talked about the threat level and the attackability surface. So many times we think about the database as a black box, and even if we understand that it's running on an operating system and we will harden this operating system, many times we don't take into consideration the 3 layers that are working each time something or someone is connecting to the database. First of all, we have the connection layer, which means there's some sort of a TCP IP connection that is happening between a specific source to a specific destination and is connecting and running to the system. And when exactly it's running and when exactly it's connecting to the system, the main question is not just about running this specific command, but also when exactly did it happen and how exactly did it influence the connection to the database. A connection layer can run which means on a clear text over TCP/IP, or it can work over SSL connection. But the connection layer, anything that happens in a connection layer, it doesn't matter if it's a denial of service attack or some sort of exploitation, it won't even be available on the database server. You won't even see the logs for this of someone trying to penetrate your database. And when we're talking about database application protocol, which is the second layer, right before the authentication layer and right before the SQL grammar running to the system, We are talking about the option for someone to manipulate multiple level of connection and even sometimes to bypass your database authentication layer. And only after those two layers have been inspected and have been authorized for access, only afterwards we are talking about the SQL grammar. And when I'm saying SQL grammar, I mean the actual SQL commands that run post-authentication to the database. And this is a different level of threat, which means can cause to running through unauthorized location inside your database, retrieving information from cross-company authentication. How can someone actually steal all this information from your database? Runs through SQL commands. And SQL commands are the basic language that people talk about retrieving, updating, or changing information inside your database. So after we took into consideration this part and this effect of information, we're talking about the thing that many companies take as enough is implementing a web application firewall. Don't get me wrong, a web application firewall is extremely important. And when I'm saying it's important, without a doubt, the option to secure your web servers and your web application is only by running a successful intrusion prevention and detection to your web application. And today the most common solution for that is running a web application firewall. But the thing is that a web application firewall only understands the HTTP traffic. And when it understands the HTTP traffic, it means that you have the option to truly intercept and to secure anything that at the application layer. But the only way that a web application firewall is able to detect SQL injection attacks is by looking for signatures. Maybe an apostrophe, maybe a specific union command, maybe some sort of a manipulation over your HTTP headers, some sort of an insertion inside a post command to your web application. But that's the only way that a web application firewall can detect and enforce security solution at the web layer. On the other hand, a database security analyzes the SQL command, as well as the connection to the database, as well as the protocol available to connect to the database. And this is something you have to take into consideration, otherwise you will never be able to even be aware if someone have run a successful or a non-successful attack to your database. Which exactly solutions are important in order to secure your database and secure, as I mentioned before, the company? So trying to understand what exactly it means, a database security solution. The option to actually detect and prevent SQL injection attacks, it's not enough only to detect them at the web application layer. When a SQL command is running to the database, there are three different mechanisms that you can actually enforce at a SQL layer in order to detect a SQL injection. First, and most common one, is in order to know which exact commands are running to the database, which exact commands are actually are able to retrieve information, which exact commands are able to update information inside the database, and to have the option to enforce this kind of policy. So blocking SQL injection, first of all, it's about knowing which exact commands are allowed and which exact are actually shouldn't be run to the database. The other way, anytime someone tries to map your database, meaning they run a brute force attempt on a name guessing of your column names, of your table names, sometimes it's your instance name, sometimes it's your database names, in order to try and map the database. Many times it shows that someone is trying to run a blind SQL injection commands in order to know exactly where it's heading. You will try to name guess the database structure. Separation of duties is one of the things that started to be really common the passing year. When you have a DBA running in your system as an outsourced service, or maybe even sometimes as an internal service, you need the option to enforce policy so the DBA won't be able to retrieve sensitive information from the database. And when I'm saying this, I mean that the DBA should run any required administrative commands. But on the other hand, he should never have the option to retrieve sensitive information from the database. And vice versa, your application developer or your local CRM representative, he should have the option to get to sensitive information, to run the sensitive commands, and even to delete information. but it should never have the option to run any sort of administrative commands. Separation of duties actually started about 15 years ago by Oracle, when they released the first version of Oracle Vault. But to many other database vendors, they don't have a solution. And if you are using a MySQL or using a Microsoft SQL Server, you have the option to create multiple authorization to multiple DBAs. But if someone will use DSA, you won't be able to limit them. And if you know the exact segment the DBAs are connecting from, and you know that they're probably not working from home, or if they do, they work through a VPN connection to your organization, you should limit that the administrative command should only run from this location inside your network. It will only be allowed to be executed using a specific usernames or a username groups. So separation of duties provides you the option to take control regarding who's able to run administrative commands to your database and who's able to provide the option to retrieve sensitive information or even just delete sensitive information. Database firewall is the baseline for database security, which means you need to make sure who exactly is able to connect to the database. And many customers will say, listen, the rules that we are talking about inside a database firewall, I can also configure inside my database application. You are correct. But the thing is, will it create additional connection to the database? Two factors are talking about the performance of your database. It's not only the number of transactions per second that runs to your database. It's mostly the number of connections that are created to the database. And this is something that you have to take into consideration. If a database firewall is configured properly, you will not have unnecessary connections running to your database. No one will even start authenticating with your database or writing even a brute force attempt authentication to your database if a database firewall is removing the connection, and it will never approve an unwanted connection to run to your database. And this is a very important fact that you have to take into consideration. A database firewall will tremendously reduce the threat of accessing to your database. And this is a very important factor. Intrusion detection and prevention, which leads to a real virtual patching, means that database vendors are releasing security updates from time to time. Many times, in order to update those security updates, it will require you to have downtimes. And as a software as a service providers, you are never able to afford downtime during the weekdays or even the nights. You have to schedule your own IT operational time and take the part of the infrastructure that you can afford in your least busiest hours in your infrastructure in order to update the security updates. And a virtual patching intrusion detection system, actually, and intrusion prevention, will reduce the threat of those types of attacks. They will never be forwarded to your database, which means you can afford the option to install your patches and security updates in your own scheduled IT operational time. Moving on to auditing. It doesn't matter if you have to comply with regulation or not. To have a full database activity monitoring regarding who is running administrative command to your database and who is not. This is something very important that you have to be alerted. Anytime that someone or trying to run administrative commands or trying to access sensitive locations inside your database, like sensitive columns that might contain credit cards, that might contain customer information, you should be alerted. And you should have the option to also provide an audit trail, which means advanced auditing, as I've written here before, to have a clear before and after of any change inside the database. So you, as an IT infrastructure manager or as a DBA or even as a security professional, will have the option to know exactly who changed what inside your database. Sometimes it's about changing the user credential names, but sometimes it's also about changing a column named discount amount to your application and to your customer. So auditing is a very important factor of your overall monitoring of your system, even if you don't have to comply with regulations. Regulation have caused a major overhead for a lot of companies, but the option to take the good part of the auditing in order to get a better security, a better monitoring regarding what's happening from your application to your database, this is a very important fact and important factor. Talking about performance, as I just mentioned before, your database is probably able to run a massive amount of transactions per second, sometimes thousands, sometimes even tens of thousands. But the thing is that you should have the option to make sure that the performance is not degraded, not by an error SQL command, nor but a specific option of people that are trying to actually run those commands to the database. So when we're talking about performance, there are two main things. First of all, it's what's called the protocol optimization, which means reducing any unnecessary fields from old protocols. You can have the newest database server running in your infrastructures, but sometimes an old legacy application or even a driver running in your most common application can use a very old variation of the communication to the database. The database will work, but it will cause you an overhead when it comes to performance. So a serious security solution should also have manner regarding understanding the performance overhead, and also in order to reduce denial of service, reduce tremendously the amount of denial of service. When I'm talking about performance, many times people talking about caching. So caching is also important, but the problem with caching is that many times people don't cache sensitive location because of the fear that information won't be relevant, or maybe information that is not updated is provided to the user. So the caching should be what's called a change-aware caching solution. You should have the option to monitor exactly what's happening inside your cached information, and this is something also that is extremely important. The last and not least, when I'm saying masking. Masking is a tool for you to provide access to your internal resources, even to a non-production system. For example, your training division, your QA division, your testing environment division. When your divisions are working on your production system, there is no justification for them to see sensitive information. So sensitive information should be masked, and when I'm talking about masking, it's about the option to make sure that columns that contain sensitive information will never be available to unauthorized source. And I'll give you just another example. If for some reason someone was able to penetrate to your web application, by generating a command to retrieve sensitive information from your database, a masking solution will make sure that an information leaving the database is already masked. Masking can be very simple as credit card masking, seeing only the last 4 digits of the credit card number, or it can be even changing the entire number to zeros or X's or any types of random numbers. So the option to mask sensitive information without a doubt is also extremely important when it comes to the option to enforce a multi-layer security. So we talked before about how big of a threat for a software as a service platform to SQL injection threats. And yes, you can say that your application have been hardened by the best consultant in the service, but many times there is some sort of a legacy application code that is being used in your infrastructure. Many times a different type of application that even it's not exposed to the mass amount of users that use your software as a service is still vulnerable to SQL injection commands. And the only option to provide a real layer to prevent SQL injection attack, it's a multi-layer database security solution. Without a doubt, the option to detect SQL injection at the database layer is very important, but more than that, it's really important for you to enforce a database firewall. Unnecessary commands should never be revealed and should never run to the database. Separation of duties. No administrative command, even from the most common ones like show tables, show databases, should ever be executed from your web server. No administrative command like running backups, for example. If you remember, in one of the most biggest attacks of the past few years in Sony, someone eventually saw in the logs that they were running backup and they were running restore from the web servers. So separation of duty is extremely important. Implementing risk-based policy, which means in intrusion detection and intrusion prevention system that will detect any unnecessary commands and unnecessary threats or vulnerabilities running from your web server to your database. Enforcing masking for sensitive information. Even if someone took over your web server, they should never have the option to retrieve sensitive information from your database, even if it's the most simple commands that are generating from the web server IP address. Learning mode and SQL injection query grouping, it means that any common database security solution will have the option for you to run the option to learn which exact commands are providing a higher level of threat, and in order to group those threats and to decide whether you would like to enforce them or not. And the last and not least is enforcing auditing to administrative commands and to see who, when, and where exactly they accessed inside your database. And only by enforcing all those layers, you're able to truly secure your database and to secure the access to the database. So the past 40 minutes I was talking about the concepts and the understanding regarding where exactly are the flaws in your infrastructure. And the thing is that in GreenSQL, we took the liberty in order to try to see the bigger picture, to tremendously reduce the attackability surface of the threat inside your database. And when we're talking about GreenSQL, first of all, it's really important to explain that GreenSQL works as a reverse proxy, which means once you install GreenSQL, all your application, it doesn't matter if it's your web server or even if it's your development studio or QA applications, are connecting to the database through the GreenSQL. Most of our customers install GreenSQL as a dedicated server. It doesn't matter if it's a physical or virtual, you can install it on a Linux or a Windows server, but all the application go through this proxy system. And by connecting through this proxy system, no one should have direct access to your database. And this is a very important point that I'm mentioning here, because once someone is able to connect and to run an actually full command to your database, the thing that happens is can you hear me now? I apologize, there's some sort of probably of a connectivity to the GoToWebinar session. Can you please just type down if you can hear me now so we can continue? I apologize for the inconvenience. I just saw that the connection was re-established. I apologize for the inconvenience. Can you hear me now, please? Thank you, Gary. Okay, very well. So, as I mentioned before, working as a reverse proxy, meaning that how can exactly you can reduce the threat of your database entity. And when your database entity is running inside of your operating system, and someone have access to this operating system, it doesn't matter if you were able to take control of your web server, or even if it's a local developer, it's already a threat for you that someone can connect using a separated connection to the database server in order to run commands to the operating system. And this is something that you should, without a doubt, take into consideration when we're talking about reducing the threat of your database. Working as a reverse proxy provides you the option to truly camouflage where exactly the database server is stored. And this is something that we do in GreenSQL. Once you install GreenSQL, first of all, we reduce the threat of your entire database entity. What exactly is available in GreenSQL? So the entire feature of security that I just mentioned before, including the separation of duty, the entire feature set of dynamic data masking that I mentioned before, the entire feature set of auditing that I just mentioned before, and with that, it comes as a software-based solution that also supports databases in your premises or a cloud, and also a cloud-based database service solutions like the SQL Azure and Amazon RDS as well. So in GreenSQL, we provide you an all-in-one solution. And not only that we provide you all-in-one solution in order to enforce multi-layer database security, but there's also a synergy between the different features inside GreenSQL. So not only that you're able to run a database security policy or able to enforce a masking solution, but the integration between the different components will provide you a much higher and better level of security. So talking about GreenSQL and what exactly I just mentioned before, and this is again really important to talk about, that the move to the software as a service. This is a huge thing that happened the past 10 years. And when I'm talking about the past 10 years, as I mentioned before, this is a common enterprise high-level design that many of the solutions that were only installed and only being used in premises have been changed to work as a service. And as a software as a service provider, when you store all the company's information, it doesn't matter if it's their customer information, if it's the financial information, the HR, or even just a basic information. Taking control of this information, this is the important part for software as a service. And trying to understand the threat economy behind why should attackers put their actually target in a software as a service, because in one successful breach, they can get all the information that you can imagine. And this is just from the past few months that you can see that Evernote, 50 million users and password have been successfully stolen. In Living Social, 50 million. So for the last time, what I'm saying, and this is every time, the database is the company. And this is something that you have to take into consideration. I would like to thank you for your time. And if you have any question, I'm just seeing a few questions right now, so let me just quickly answer them. Well, we have a question regarding the beginning of this session, and from what I see, you have an invitation for 10:30 a.m. ET, and we started actually at 11 ET. So there might be some sort of a confusion, but this session was recorded and should be available for you tomorrow over YouTube. So I apologize for the inconvenience regarding the time scheduling, but you will be able to see the session also tomorrow, the full session from the beginning, sir. I apologize for that. So I understand that the session probably was supposed to start at 11:30 and we started at 11. So I apologize for that. And besides that, if you have any questions, we currently do not support DB2 platform. We believe that during next year we will support Oracle database as well. And we will send, by the way, to the entire list of people who registered for this query, a link for the YouTube session. Should be available tomorrow for you people. So you will receive an email with a link regarding where exactly you were able to see this presentation and this session. If you have any other questions, I'll be more than happy to answer. Oracle is not supporting because at the beginning we decided to focus on Microsoft SQL. There was a question regarding our support in Oracle database. So we decided at the beginning to support the mid-size and the mostly common used in a cloud environment databases, which are the MySQL, PostgreSQL, MariaDB, and Microsoft SQL, which was also really adopted the past few years. And Oracle will be supported next year as well. I'm talking about version 11 and above, should be supported, we believe, sometimes early next year. We've been working on Oracle for quite a few months now, and it's a hard work because it's much more complex than the databases that we currently support. Any other questions? I'll be more than happy to answer. I got an interesting question regarding the overhead. So when we're talking about GreenSQL working as a proxy, and we are actually a front end to the database, when it comes to enforcing a security solution on your database, the overhead is a question regarding three main factors. The number of transactions per second that you run, the number of connections that are open to the database, the size of the query that runs to the database, and also the size of the response that comes out from the database. The overhead should be less than 1% without enabling the caching, but when you enable the caching, you should actually get a performance acceleration and not degradation to your database. We'll be more than happy to run a POC with you, sir, if you're interested, for the person who has this question. And when we're talking about comparing the connection to your MySQL, and as I mentioned before, it's really a question of the type of the commands that you run. We have some of the biggest online gaming companies worldwide that use it with a massive amount of transaction per second and securing tenths of different database servers. So regarding performance, we got to the point where people are accepting the solution without an overhead on their infrastructure. So we'll be more than happy to run a POC with you, sir, and you're able to download the solution online, and you'll be contacted by a system engineer that will be more than happy to assist you regarding any configuration and implementation of the solution. Another question regarding DB2, Microsoft SQL, and Oracle. So at the current time, ladies and gentlemen, we are only supporting Microsoft SQL, MySQL, MariaDB, and PostgreSQL. We should be adding Oracle next year to our supported database. DB2 is currently not in our immediate roadmap. We believe that within a year and a half or something like that, DB2 will also be provided as well as Sybase. But we cannot guarantee and provide a specific time schedule for those databases to be released. The connection managed as a proxy for the two different, I can only answer regarding the supported database. Even though we spent a lot of time researching the Oracle connectivity, it really depends on the type of Oracle that you use and the type of application that you use in order to connect to the databases. Okay, another interesting question. What are the core set of new functionalities in security features provided by GreenSQL that is not available by the native databases? One of the main thing and the most important one that you can actually add it in your database, but you will need to have an additional database server. I will explain what I'm talking about. When I'm talking about the database firewall, and I'll even connect in order to show you what I'm talking about. So this is a system that runs in our QA environment. And let me check if the password works. Yes. So this system, this is a GreenSQL management interface that you can see in front of you. When I will go to a database security, you have a few different factors that you can enforce. You have three different laws. First of all, a learning mode. And a learning mode means that the system will automatically study each and every query that runs through the system, and you will be able to then to enforce it in a whitelist or in a blacklist, which means I'm allowing only a specific query that runs through the system. I'm allowing only a specific set of queries to be blocked. So the system will provide you the option to run a learning mode policy, and only after the learning mode policy have been executed, you'll be able to enforce a specific group of queries actually to run inside the system. The second thing that you cannot run in your database firewall, in your database application natively, inside a database solution you have two types of policies, a query group in order to enforce the specific query group that have been learned at the previous policy, and to enforce whether you'd like to allow it or to limit it. But more important than that, you have the option to decide, including up to an application name, who exactly is the source that you are allowing to access your database. And this is a very important factor, because you can say that, listen, inside my database application, when I'm running management, I can still decide who can access or not. You are correct, sir. But the thing is that unnecessary connection will never be created to the database. If, for example, I decided to limit my QA IP address and decided to enforce that only user root using my QA IP address, you'll be able only to use Microsoft SQL Studio Management, okay? He should have the option only to run administrative commands. This kind of policy you cannot enforce with your database application. Another level which is really important, if in your system you have a QA division, so take a look at these two policies. The first policy is I'm saying the access to any database, and I'm running a learning mode. When my QA team is running a specific user, say for example, all the query that they are running should be stored inside a group called XXX app, for example. And the other policy in this list is enforcing that anyone that runs from my web server using a specific user should only be allowed to run queries inside my XXX app. And this is a very important example, because if I have a learning mode, a QA team or QA person inside my organization, only connection that have been approved by your QA team will be automatically enforced to your web environment. And just by enforcing these two rules, you're able to extremely easily increase your security by more than 90%. Because only queries that have been generated by your QA environment should be allowed to your web server in production. And in these two rules, you can actually accelerate your security, as I just mentioned, by more than 90%. Another, something that you cannot run inside your database application. When you create a rule, you have a third type of rule, which is called a risk-based. And as part of the risk-based, you can run it as an intrusion prevention or an intrusion detection, which means you can run it only in a monitoring mode or only also in a protection mode. This tiny SQL injection mechanism will run the three mechanisms that I mentioned before. The option to detect any brute force attempt on the database to detect name guessing of a column name, table name, database names, and instance names. The second, if anyone is trying to break a query that was running with an apostrophe and to add any type of administrative command, even the most simple one as show databases, it will be alerted and it will be blocked, so it won't be able to run. The third is any type of SQL tautology. I don't have a lot of time now, so I won't get into it, but you're able to run an SQL tautology command in order to make sure who's exactly running a command to your database, sir. And another something which is very important is the option for you to create your own risk profiles. And when we're talking about risk profiles, you have the option that when you'd like to create a risk profile, for example, Microsoft SQL, we talked about that. We took all the available possibilities command inside this protocol and we have divided them to 5 main categories. And you can really easily decide which type of object you're allowing to view, to modify, to create, to delete, or also to run. If you're an advanced user and you will go to advanced mode in creating the risk policy, we are providing you all the different possibility inside the protocol, which means you are able to create, and by the way, if you don't understand, for example, what's a view endpoint list or a view error messages, you can have an explanation pop-up. View language, what exactly it means, or view lock timeout. Okay, so you have a pop-up with explanation regarding each and every feature of the risk-based policies that you can enforce. This is also something that is not available at the database application. The entire feature of masking is also not available inside your database application. And just to explain you how easy it is to enforce this type of command, if I will choose my database that I would like to protect on, and I will choose my specific column, for example, under employee, I would like that my login ID information should be masked using masking behavior of mask all digits. This is not a digit, so naturally it will not work, but let you just mask all with the character X. Anyone that is accessing from my QA environment should see only X's when it tries to retrieve the locking ID field. And this is working at the request command, not at a response, which means that the sensitive information will never leave the database, and this is a very important factor for you. Okay? And those are, I think, the main things that you cannot run inside your database application. Another question. We have a question. Can one connect to the database directly also while running GreenSQL firewall? Yes, GreenSQL is a reverse proxy. Once you install GreenSQL, it's really important for you to make sure that your database is not accessible by anyone but the GreenSQL. Some customers put their database behind a firewall. Some customers configure an IP tables on their database server in order to make sure that no one besides GreenSQL is connecting to the database. But more than that, we are also in the process of developing an agent that will be installed on the database server. And this is in order to make sure that if anyone is trying to connect, or even if you just connected a screen, a keyboard to your database server, you'll be able to see and to make sure and to monitor if someone is trying to retrieve the sensitive information from the database. So this is also something that we are taking into consideration, and it's in development at a specific time set. Okay, I don't see any other questions, so I would like to thank you all for joining us to this session. And if you're having any needs regarding demonstration on site but that we can do remotely, or a POC, please feel free to contact us at www.greensql.com. And I hope to see you again in our next session, which will be next month, very soon. Thank you again, and have a great day.